Nice.
Wonderful. Wonderful. Good morning, Wendy. How are things in Wisconsin?
Okay, now you can hear me.
Yeah, we can.
Not to loosen clouds.
This is a big theme on Wikio right now, this not to lucent clouds. So I think we could even have a whole discussion about not to lucent clouds. I know I'm learning a lot.
Very cool.
Awesome. Thank you. Miss Lindsay, how about you?
Okay, I think I successfully unmuted today, maybe.
Yay.
Okay. I am an excited particle. So my electrons are in the energized state, and I'm running around bumping into things and seeing if I can charge exchange back.
Awesome. And because I work with you so closely, that is just, I have that image. I know exactly what's happening at the Adler today. That's great. Thank you. Nancy in Texas, how about you this morning?
Well, I don't have the technology gremlins today, so that's a good thing. Yay. So today, and I really did think about this too, I decided I am a dwarf nova, which is a nova very similar to anything else, but it's a binary star system where you have one star that's actually accreting its matter from its companion star. So I'm the one that is accreting knowledge and matter from everybody else, and that's where I'm at. So.
Excellent. Excellent. Thank you. All right, Miss Nagy.
Okay. I am also an aurora. And the reason is because it is my reaction to the ultra-high energy particles bombing the magnetosphere. Change and learning is hard. We keep our content and beliefs tight around us to keep us safe, like a blanket. The magnetosphere is like my personal blanket. There's a blast from the sun, who's you, and it stretches my blanket, making it so thin that some of the high energy knowledge gets through, sparking beautiful visions inside my world.
I am just so impressed at how these things that I have often had as a destructive force, everybody's turning into this very big force of possibility for me. I just feel so fortunate to hear all this morning. Thank you so much. Jim, how about you? Just Jim today. No Yoda or, from Starfleet?
Not yet. I was in a hurry. Before I start, I just want to tell Nancy in Texas, that's great. You want to do that, but just don't exceed the Chandrasekhar limit of 1.4 solar masses. Otherwise, you'll go nova, type 1A supernova. So be careful. But anyways, I think in keeping in theme of everything today, I think my knowledge has expanded, from this discussions yesterday. So I think I'm going to go with the dark energy dominant era, where about 5 billion years ago, dark energy overtook gravity, is causing the acceleration of the universe to expand. So I feel I'm expanding my knowledge base by sharing all these ideas with these fine folks here today. So dark energy dominant era, I think I'll go with that.
Dark energy dominant era. Very specific. Thank you. Laura Orr, good morning.
Good morning. I'm going to go with Doppler shift because there's a lot of energy, but it takes a lot more study to figure out which direction it's going. Not sure yet myself.
Fabulous. Fabulous. Good morning, Darlene. How about for you? She can hear me.
Oh, okay. Sorry. Taking notes is I was trying to keep up with everything people are saying. I would say I feel like a CME, a coronal mass ejection. I was sick all last week, and so I conserved a lot of energy, and then now this week it's just blasting forth with all sorts of good stuff here and there and everywhere. Lots of energy, lots of stuff in all directions. Some of it will hit you.
Maybe help exchange energy with Lindsay's excited particles.
Yes.
Thank you. Good morning, Diane. How about for you? No, Diane? Maybe she's...
There I am. I'm a near-Earth asteroid, and I cruise in and pick up speed and change direction and come back later.
Okay. Thank you. That's a great description. Ricky, how about for you this morning?
I'm a meteor shower, just traveling through and looking for a place to land.
Traveling through and looking for a place to land. What amazing imagery. This would make a great, what great story starters. Okay, like talk about cross-curricular here. These would be great story starters. Fabulous. Well, let's go right into then,
Wait,
looking
I
at...
have to go.
Oh, Nancy, I'm so sorry because you were the first one on the list and I didn't want to make you go first. So
That's okay. No problem.
you are.
I'm happy to go last. So the phenomenon for me, yesterday during our break, I went outside and looked up at the sun, and there was a rainbow halo around the sun. And that's the first time in my life I've ever seen that.
Oh.
And it was pretty special. So that is the one, obviously, that I'm going to choose for us today, because I feel like we are that rainbow circle that is around the sun.
Lovely. That is very, very beautiful. Very beautiful. Thank you. Yeah, I'm so glad that Lynn put that up, because I was saying, is that a sun dog? And then when it's the moon, it's a moon dog, right? Is that what, I don't know, maybe a technical life for rainbow halo?
I think that there's a slight difference between them, because I think a sun dog is when there's a double image of the sun on the side.
Okay.
So I believe solar halo.
Solar halo.
Maybe
Fabulous.
also
I remember having that conversation before about what a sun dog was and wasn't, and didn't matter. Well, Claire, it's nice to see your lovely face.
Sorry I'm so late, guys. San Francisco traffic at 8:30 in the morning is it's completely unpredictable. It could take me 20 minutes to get to work, or it could take me an hour and a half.
Oh, goodness gracious. Patience must be a very big virtue in San Francisco.
It's all right. It's worth it. It's okay.
Well, we were just finishing up of describing our astronomical phenomenon of how we're feeling this morning. What would be yours? Not to put you on the spot, but you're the last one.
I feel like a rotating vortex. Everything just keeps moving past me, and everything is getting sucked in, and it's all, it's unable to keep up with all that has to happen. It's been one of those days.
Well, we're glad you're here.
I don't know if it's technically an astronomical object, but that's on the fly.
A phenomenon. It's a phenomenon.
Absolutely.
Thank you.
Good morning, and I apologize for my tardiness.
It's all good. We're glad you're here. Very glad you're here. All right. Well, what are any thoughts or things that came to us from yesterday's experience? Any more additional things, or somebody who wasn't able to speak yesterday, or something that changed or shifted?
Just a quick timeout. This is for Vic. It's Subrahmanyan Chandrasekhar. He won the Nobel Prize 1983, I think, in astrophysics for the Type 1a supernova. So it's a Chandrasekhar. In fact, I think the Chandra satellite or space
named after him.
Spacecraft is named after him. Shekhar. Yeah, it's a tough one. Yeah.
All right, thank you.
Pronounce it for me one more time.
Okay, Chandrasekhar.
Just Chandrasekhar.
Shekhar.
Okay, thank you.
Fabulous.
Chandrasekhar. Yeah.
Sekhar? Somebody should type it in the chat box.
That doesn't help with the pronouncing, but yeah.
I thought it was Subrahmanyan Chandrasekhar. I used to be able to say it. So.
Hey, really quick, you guys, I wanted to chime in since I'm the timekeeper for today, and I want to introduce you to my 5-minute sound so you guys know what it is.
Thank you, Dar, yes.
It is my 3-year-old girl's woofer guitar, and it goes like this. Can you guys hear that?
Yeah.
All right. So that will be your warning.
Thank you.
Sure.
Oh. All right, so thoughts or pieces that maybe you weren't able to post. I saw there's lots of activity online and questions and resources, but thoughts about yesterday's experience as a whole in general.
The only thing that would have made it better was all of us being there in Berkeley.
Absolutely.
There was a lot of communication, a lot of ideas being exchanged, learned some things, which was very good. It was phenomenal. I'm glad that I'm a part of this group.
We are too.
Thanks.
I was very pleased at how you guys arranged the agenda, because when I first saw the time, I was like, 8 hours of sitting and looking at a computer. Wow, this is really going to drag. But it went by fast, and it congrats to you guys for developing a very strategic and smart agenda. Thank you for that.
I'm glad it worked for you, Jane, and you especially. Are you more comfortable today? I'm going to be messaging you all day. Like, are you caring for yourself?
I have some bar stools in the kitchen that have padding on them, so I'll go get one of those after a while.
Good.
I was amazed how fast it went also, because again, I was dreading the amount of time, but once you became involved, it went so quickly, and that means you got me hook, line, and sinker.
Time flies when you're having fun, right?
It does.
I had a different question I was going to ask, and now I lost it. Just flew right out. I was like floating somewhere around here. I'll grab it later. I was really excited. You know, I know that there are people in this coordinators group that have worked with many of you. And me being new, I didn't know anybody, and I had seen a few names and on papers and you know, in different pieces of work that I do, but you know, so it was really an interesting thing to have a list of names that, you know, and to hear from you the first few phone calls, but then to see your faces and get to know you. I was so glad we had all those Zoom tests, because it was really fun just to be informal and kind of readjust to re-meet all of you, and it was just such a rewarding experience. I loved the variety and the spectrum of what people have to add, and I've been fortunate enough to work with groups of people for a very long time, and I love how I always get to see in a different way that the whole is greater than the sum of the parts, and I really experienced that yesterday, the vast richness, and you know, how broad this field is, and all the new ideas that I felt like there was so much more for me to be interested in, and I just felt like I was floating very much in the middle and being supported from below, but being drawn up above. And so what a rich group, and what an amazing constellation of people you all are. I am so, it was just such a great experience to work with all of you yesterday. And I'm looking forward to much more time with all of you. Well, let's look at our preparation work for today. Not our homework, our preparation. And I'm wondering, did anybody, you know, looking at the IRIS mission launch, you know, even though some of the information, a lot of it will relate to SDO and how we looked at that presentation yesterday, because it is an upcoming mission, there is a possibility of being involved with it from launch and on through it. What are some ideas that people came up with how they thought that could be best be used or incorporated in what you're doing in your classroom?
one of the ways that, oops, I just lost me. One of the ways that that I like looking at these different missions and pull them into the class is we do get on NASA TV and we do look at some of the archived launches. And I think it's really interesting that this one is being launched via Pegasus, which is, on the plane or underneath the plane. And that's something that certainly my students can take a look at and look at the differences of that type of launch versus, a full vertical launch. And, with 6th grade to 8th grade, they can do some engineering, and maybe they can, take that information and create maybe another way of launching some of these. But I like that we are going to have something from the very beginning, at the beginning of the school year, that my students can follow, because I think that is also important, that they can follow something from beginning, all the way through. Some of the activities, I was on the website last night, and it looks really great. I mean, it's a really pretty, okay, and I know that's all pretty, but it is. It's just really pretty. It's very visual. It's something that will certainly keep my students engaged, and I'm looking forward to doing a couple of different web quests having to do with IRIS as well as with SDO. So this is where I hope to get by Christmas with some of my students.
Wow, Nancy, thank you. That's amazing.
Well, Andy, I can look at this when I began to, both with my freshman physical science and with my physics, to when we get into discussion, the difference between temperature and heat. And that region right in that hole, that as described, is, to me, it kind of almost mirrors the mesosphere, where you've got a tremendous amount of high temperature, but really no heat. And so, and then also, we do a fair amount of spectrum work in physics. So this will be a nice place to, shall we say, introduce the topic with the actual satellite and what it is doing.
Fabulous, and thank you for bringing the difference between heat and temperature, Vic. Thank you. Are there any middle school teachers that work with optics? Vic mentioned with the spectral work. Are there any middle school teachers that use optical physics that bring in wavelengths or anything like that?
Yeah, it was actually going to mention when we study deep space and far space, inevitably the question comes up, how do we know what we know? We can't get there. How do we know all of this information? So we talk about how scientists analyze energy and radiation. And, okay, so I told them that, but now I feel like with IRIS, we're going to have some more data, some more options to actually put it in their hands and let them look at different spectral analysis and help them to figure out how we know what we know about, our sun, and then apply that and connect it to deep space objects and other planets and other galaxies and items of that nature. So I think that'll be pretty cool.
Same here with us, and that is that part of the middle school standards that we have, they do have to understand what the visible light spectrum is. They need to be able to identify it on a full, wavelength scale. And so that's, in 6th grade, they start learning about the visible light spectrum, but in 8th grade, they actually have to know where it is. Not necessarily the measurement of the wavelengths, but they do need to understand where it is. So, and yeah, like with Jane, they definitely have to be able to take that information, and they need to be able to apply it with distances in space.
That's great that you're working with that, because I know not everybody has that opportunity, or it might not be built into their curriculum. So it's good to know that that's happening in places, because it is so essential. There are such amazing pieces that need to be in place before they. I'm using the word need. That would be very helpful if it was in place. I think it needs to be in place, but that's my agenda. Anybody else?
Yeah, go ahead, Vic. Well, go ahead.
Okay, I was just going to, Laura mentioned in the chat on how the kids would use that to tie in to a project. And when Themis launched their rocket, my geology class, we had a rock party where we had rocket cakes and crispy treats, but it sounds kind of bogus, but they followed that program for the rest of the year. It became theirs. And so there was a big buy-in when they started it with the rocket launch.
And that's true not only of students, but of everybody. If you're invested right from the beginning of something, you feel like you belong to that mission or that sort of endeavor, which is, you know, that's definitely making it your own or making it personal helps enormously.
With Spectra, I guess more with the high school students. If you know, when you're in doing waves and energy and stuff, you can also do the famous question: how many photons are needed to heat like 20 grams of water 15 degrees? And a lot of people have no idea about microwaves. You can say they're about 12.5 centimeters, and you can. It's a real good problem. You can use the Q equals CM delta T formula to figure out how much heat energy is needed to do that, and you can calculate how many photons are needed by using a microwave oven. And that's a real good one for maybe the upper kids here, and that way they have an idea about what microwaves are and how they because everyone uses microwave almost on a daily basis, but they have no real idea behind that. And with Spectra, a real good Spectra test you can do at the high school, even with freshmen, is the flame test. In particular, if you have if you can get lithium and strontium and you burn them using like a was it wood rod, you know, like wood stirring, like you stir coffee with. If you burn those, they both burn red. So you can't differentiate which is which. But if you get a spectrograph, or if you get like a spectrometer, and you have them look at it during the flame test, lithium has one distinct red line, and strontium has multiple red lines, and that's a good way for them to get an idea how to use spectra for element identification.
Can I jump in? I'm a middle school teacher, and one of the things I want to bring up about teaching optics is here on Maui in mid-September, we have the AMOS conference, and that stands for Advanced Maui Optical and Surveillance System, and we get all these really unusual like high-tech optics people coming in, and my students are exposed to all that as a career. And then the university here also puts on activities for the kids to get their hands on optics, and it's very wonderful. But they need to know the background before all that, and I've recently come into, I have a whole classroom set of those black plastic boxes. And they're the spectrographs that you can buy from the different science supply. And I'd like to use them more. And I'm wondering how I can use them and then link it to the information on the IRIS site, because that's a great big spectrometer, and my kids will have those little ones. They're not so little, but I'd really like them to be able to use them more than just once to look at the sun. Help?
Well, maybe I can help you on that one. We use those more than just when they're looking at the sun and looking at wavelengths, or just, you know, looking at different colors. We use them, as Jim had said, we do flame tests. With my 8th graders, my advanced 8th graders, we do flame tests to look at the chemical, you know, what chemical they may be burning. So when you use those boxes, you can look, like you said, you can certainly look at the flame that's burning, and you can see the different colors in there and the spectral lines. But we use it in chemistry because it does differentiate between certain chemicals when you are burning them. You can also use them with just different colored light bulbs, whether it's using incandescent light, using a black light, using anything else. But it can always be linked back to chemistry, to the periodic table. Again, because we have, everything in the periodic table is going to have something a little bit different on it. And those are the ways that you can link that in there besides just using it for the optics. I'm hoping that helps a little bit more.
Oh, yeah, it does. I put a link. This is from University of Oregon. Awesome link. You click on it, you have absorption and emission spectra lines, and it gives it for all of them. So it's pretty cool. You can use that for identification.
So do they look through the box on the computer?
No. They actually get a spectrograph, and they look. One person goes like this and looks. The other person, eyedroppers work better. You get a flow of a metal or like in solution, and you drop it into the flame. And when it flames up, you look at it, and you can get the spectral lines. But it's kind of hard unless you have. See, I have the real cheap spectrograph, so I just use strontium and lithium. That's it. That's the easiest one to look at, because one has one distinct red line, lithium, and strontium has 5 red lines, and so it's easy for kids to differentiate between the two.
Yeah. And this is where I'm fortunate with the school that I teach at, because I do teach, it's Space Center Intermediate School, and I'm right across the street from Johnson Space Center. And when we're doing certain tests like this, because I may not be certified to handle certain chemicals, because in our state, there's different OSHA regulations that you have to abide by. So I may not be certified to handle those particular chemicals, but I can call somebody across the street at NASA, and I can get them to come over and they can demonstrate this for my students. So what we'll have is I'll have one student that's actually looking at the flame, and then I'll have him or her telling another student what colors they need to be looking at. We already have a graph that's set out for them to be just to be putting in those colors. They can either color it with their colored pencils at that time, and then put the spectral lines in where they see them, or they may just write the words. It just all depends on how it works for those particular students. And again, for me with the 8th graders, this is certainly my advanced classes, not my regular or my special ed kids. They'll get, in order to modify for them, they will get the demonstration, but they won't have to identify the spectral lines.
Another thing is to give one to your student, tell them go home, and now go for a drive with their mom and dad, and start looking at all the street lights and the different building lights. They're beginning to find out there's sodium vapor, there's mercury vapor, and you'll get different spectral lines. All they got to do is look at the street lights.
That's very true. Just something that's funny that did happen this year. We had a student that did something very inappropriate and brought something inappropriate to school, and our principal came down to us down at the science end of the building, which she usually doesn't come down where we are because we scare her. And so she asked us actually to go ahead and do a flame test on it to find out what that substance was. And then the campus police officer was there when we were actually doing the test, and it was not what it was supposed to be. So that's something that middle school kids, when they do see, like you're talking about, Vic, with the when you're talking about the looking at the different lights, street lights, it is good to let them know too. Well, we can always differentiate what's being burned by looking at the spectra of it.
So instead of being astronomers or budding astronomers, you're making budding CSI agents instead.
Science is science. It all works.
as long as they're excited by it. That's as long as you promote them bringing inappropriate substances to school.
It was funny. Yeah, it was really funny because they were just, oh, they're burning stuff. Cool, so that's always fun in middle school anyway.
Thank you. Thank you very much.
I think you've got some good things to work with there, Maggie. What do you think? Excellent. Good. And I encourage when other people struggle, you know, and that's what we're all here for. So when you want a way to how do you do that? This is the community to, you know, be able to post something and say, hey, anybody ever burned unknown substances before? No, I'm anybody, you know, I have this wonderful thing. Is there some other way I can use it? Or you know, who's done an activity on this concept? So this is a great way to use the community. Any other ideas for ways that you might use the IRIS information in your classroom, or even with your colleagues? How might this be a way that you can connect with your colleagues?
Well, we're kind of lucky here in Bozeman. Part of the optics were done over at the university, and so they're having a launch party, and there's going to be a lot of activities going around town, and we are going to be using some of what's going on with the, we have the Museum of the Rockies here, and like I said, we've got the only planetarium within several hundred miles within 3 states, and so there's space camps that are going on there. Their exhibit right now is a NASA exhibit, and so at they have a sleepover camp and they have 2 one-week class camps. And we're going to be doing some of this there. They always pull me in for the astronomy type stuff, and I go and help at camp. So we're going to be bringing it to those kids and fine-tuning it and then taking it into the classrooms.
Awesome. Is there anything you would want to know more about, or about anything that was presented yesterday to, you know, even by Martha, but either by Martha or Deborah, that you would like to know more about, or might be helpful for you to know more about in order to feel like you could bring these concepts successfully into your classrooms or schools?
That is a good question. I'll have to think about it. I do know Martha is going to be here in about 2 weeks. So I'll have to.
We're all wishing we could be Lynn right now.
I know. We're lucky. We have a lot of stuff going on here with the AAS, SPD coming, and with the launch. So we do have a lot of cool stuff going on this summer, which is really nice.
Just for the record, guys, the Solar Physics Division meeting takes place in a different city every year, so it's worthwhile, you know, if it enters your head, to just have a look and see if there is any big conferences coming to your city this, you know, in the coming year, even ones that you may not be attending, because very often they will have workshops for educators associated with them. So, you know, if these kind of things are on your radar, if there's like a mailing list or something that you can sign up for what's happening in your nearby area, it might be worthwhile. You could get some really awesome resources out of it, because most of these conferences move around every year. They take place in different places.
Claire, do you have a good source as somebody on the inside that teachers could, like, where's a good, I would be overwhelmed by that. You know, I wouldn't even know what to begin to Google to find those opportunities. Do you have a good sense of what might be, how you check those things out?
I could certainly try and put something together. It might not be complete, but it could certainly be a starting point for the heliophysics community. The wider astronomy community, I'm not as well involved in, but maybe it's something we could try and do through the forums or something like that, see if there was that kind of information available. But I can certainly make a start at the Helio ones, and it could be something that we just post different links to, perhaps.
Sure, and the Helio one, of course, is going to be what's most important to this group right now. Yeah. So that, you know, that would be amazing.
Okay.
Yeah, there is through NASA Wavelengths a Facebook and Twitter feed that does make certain opportunities available. For a lot of the times they advertise educator events and workshops and things like that. But as the word gets out that this is really a place to post things, I think a wider variety of opportunities will be made known through that.
That's right, Lindsay. Isn't there there's like a calendar of events page on the Wavelength site that we could use or just provide to our community of practice here?
Mm-hmm.
That was something that I brought up to my group yesterday when we were in the small groups is, and the only thing that this thing does not have is a raise your hand thing. But I think that's the only thing I like better about WebEx. The only thing I like better about WebEx. That's probably the only thing. Is, you know, how many of you are familiar with wavelengths? And it's something that NASA wavelengths, I should say. You know, is there anybody that is very familiar with that as a resource?
You guys posted information on that earlier in the group, and that was my first time seeing that, and so thank you for that.
Well, I'm wondering, you know, we have about 10 minutes before Laura has time, and I wanted to, I don't want to cut anybody off. Is there anybody else that has, hello? Is that me? I'm hearing feedback, okay. Before I move on, that's something that we could go through real quick just so that everybody knows what an amazing resource that is. It is really rich and full and easy. I went with the K-12 group through the forums, and I worked with a couple other people, and we did a half-day workshop or classroom for the different age groups on NASA wavelengths and what you can find there and how to use it. So, but I don't want to take time to do that if we have other people that want to share what their thoughts are about using this mission information in their communities. But I think, you know, definitely is a very rich resource, and again, very, very easy to use. And it's they're developing the next phase with a lot of really neat features that I know educators will find really useful.
I think that would be a good use of the next few minutes.
Okay.
Go through that, but I'm not an educator, so maybe somebody else should. But I was fascinated by it when I saw it for the first time a little while ago. So.
Or I could even do my 6-minute presentation for you. I will spare you. I don't even know why it's right there. I don't even know why I do that. Okay. Why am I getting that? It didn't go up. Hold on, I did something wrong. There we go.